Good. Thank you very much, Phil. Thanks for the introduction. Can you hear me well? Or
yeah, we can hear you and see you. If you want to, if you want to test out sharing your screen.
Yes, let me do that. I share the whole desktop here because I'm going to be switching. Good.
Perfect.
Can you see my screen?
Fantastic. Yep.
Good. Let me reload the thing because now I'm an editor. Good. So I start the slideshow. Let me know if you can't hear or if you don't see something. Good. So welcome to the workshop today. Thanks for signing up and your interest. I think we actually booked out, which is it's good to know that there's an interest in our tables, and also on creating tables for clinical trial reporting. So my name is Adrian Waddell. I used to be the lead of a project at Roche called Nest, where we created a whole suite of tools from exploratory to regulatory to essentially analyze and report clinical trials data with R. So there's a shift from SAS towards R. Recently this year, I have moved to the West Coast. I'm now working in GRAD research, and in terms of clinical trial involvement, like that whole space of R in clinical trials, I'm still helping with R tables, but my day-to-day job is now more around biomarker analysis. Good. Gabe, please go ahead.
So I'm Gabe Becker. I'm the primary author of rtables, as well as the maintainer. And I also do consulting for other pharma companies. And in addition to that, I routinely collaborate with the R core development team to add features to R. So those are the two things that I work on these days that are public facing. The one that's relevant here is going to be R tables. So we're gonna talk about what we've built together for that.
Good, thanks. So first off, we have now finally a Hex sticker, which we plan to print at some point. So yeah, that's it. Took us a while. I hope you like it. Then the second thing, which Phil, if you could help us, I don't see on Slido how I can make a poll. Let me take Slido over. Can you make those polls, or should I? So I would like to ask those two questions. I
can definitely. If you just put that in the Zoom chat, I can kick off the poll now.
Yeah. Okay. Fantastic. So I'll put that into the Zoom chat, which that didn't work. One moment, my Zoom. So Zoom is here a little bit. Oh, here. Sorry. Now I see. Okay. Chat here to Phil. Or in Pharma, you're in Pharma too now, yes.
Yeah, you can just put in the Zoom chat. It should, there it comes.
Yes,
got
so
it.
There you are. Good. So if you could make those two polls, and then everyone, please go to and answer those two questions, those two polls. What do you expect to get out of this, and how much experience do you have? And if you can make a question, like if you can make an answer for the experience, no, little, a lot, that would be good. I think it's enough 3.
Okay, I just kicked off the one as an idea. You should see it pop up. It says, what do you expect to get out of the workshop?
Good, that's this one here?
Yep.
Good.
See if I can figure out how to do the other one as well.
Okay. Yeah, so if everyone could write some, and then we can look at that. We can then use this information to focus on various parts of the.
There you go. I just kicked off. The second one is a live poll. You should see that one in a separate place. I did them in 2 different places so we could run them at the same time.
Oh, fabulous! Thank you very much, Phil.
Yeah.
Yes, get to know our table, overview of our tables, capability producing outputs. Good.
Cool.
Good.
It's coming through.
It's good, yeah.
So we'll why don't we get started and we'll come back to that and look at the
we come back to that.
look at that as we're going through.
Good. So as you write that, what we have planned for today, and we can, it's a lot of material. We've created an end-to-end essentially training in our tables, where we have to be a little bit selective, because for us it's important to be end-to-end, and we can be selective of what we will spend more time and what we mention, and maybe just show it and then move on. So your answer will go into the forming of those of the workshop. But so we will talk about our table fundamentals. We do the end-to-end fairly quick, where we show that's how you create a table, that's how you then render it into a PDF, RTF, or text file. And then we go fairly deep into the various aspects of table generation. Or we have the content to go fairly deep. And in the end, and through the course, we every now and then mention the term package, which is a package on top of our tables to create pharma-specific tables. So our tables can create all those tables, but term adds some statistical modeling, like specifications. It adds some components using our tables to create those tables quicker.
Yep.
So yes, so maybe as the second housekeeping, the slides are available here. Maybe let me copy this URL and put it in the chat. So these are the slides. Okay, sorry, slides are here. Then the Git repo we have already cloned. The slide you have already access. Our tables documentation. You have the slide, you can click on this. Yeah, so it's the most important. So if you have access to the slide, you can view them. And we will update that which version of our table.
It's 0531.
Okay. Well, yes.
But
I'll write it right now. So we will use 0531. And the other thing is, if you please don't do that right now. We have it set up on our Studio Cloud, but you can recreate that environment on your personal laptop or computer with these codes. So essentially all the CRAN dependencies, and then you can install them directly from GitHub. It's important to note though that our tables and formatters are currently already on CRAN, so install packages our tables would do. But we have a slightly modified version for this workshop.
We have a slightly later version. We have a version that will ultimately become the next CRAN version. But so this is a little bit of a preview for certain functionality that's not on CRAN already, but will be soon. So everything you see today will be available in the next version that is on CRAN. And the vast majority of it is in the version that's already on CRAN now.
Good, thanks. Good. So Gabe, please go ahead.
Yeah. So what is rtables? Rtables is a general low-level table framework that I've been developing, working with Adrian underneath the umbrella of this Nest project in Roche that he mentioned. And it can be used to create essentially a very, very wide breadth of tables, but the focus that we have had in terms of like the design space and the feature space has always been regulatory tables intended for submission within clinical trials. So the features are more general than that, but they have since the beginning been informed by the needs of pharma specifically for regulatory tables. And what ends up, what we do is we have a and you'll see this more, but we have a sort of more visualization based approach to table generation, and you'll see, I think, the benefits of that as we move on. And then we also have a wide array of sort of rendering and formatting options that are going to be useful for various formats and various types of tables. So so yeah, so let's go ahead and just get into it. Yes. So R listings, everyone always wants to know about R listings. There are aspects of R tables, which mean that you could technically try to construct a listing, but because they have, 10,000 rows or so, like it's going to be extremely inefficient. So we actually do have a prototype that uses the same rendering backend and formatting logic as our tables, but is more efficient and simpler for listings. It's called R listings. And we're not going to talk about that beyond this individual slide, but we are letting you know that that does exist, and it will be, that one is not on CRAN yet, but it will be coming to CRAN relatively soon. And that will allow you to do listings within this sort of larger R tables family of functions as well, or packages. Right. So before we do anything, we're going to talk a little bit about the R tables conceptual model. So how does R tables think about tabulation, the construction of these tables, and how should we as users of R tables think about this process of constructing a table? So go ahead. So this is informed by what I am sort of facetiously calling the Zeroth Law of Computing. And this basically boils down to anything that's tedious and repetitive and error prone when humans do it shouldn't have humans doing it. Like, that's a computer's job, is to do those things. So let the computer do the stuff that doesn't require any thinking. We'll do the thinking, and then we'll get our work done. So we want to avoid any type of sort of tedious or technically difficult manipulations of data or objects as users. We want to let the computer do those things for us, and that's going to permeate throughout this design of our tables that we're going to present. So go ahead. Right. So many people would think that the first step to creating a table is deriving the cell values. So the numbers or strings or whatever else you want to put in the cells of what will ultimately be your table. And there are many packages where that is the first step, but that is not the case with our tables, so which we're going to see in a bit. So if you go ahead, Adrian. So we are going to treat reporting tables as faceted data visualizations. This is very important. This is the core concept of the design philosophy of our tables. And so here we see equivalent, a visualization and a equivalent table. So we can see that each of the components in the table correspond directly to an exact unique component within the visualization, and vice versa, right? So we have the rows, and you can see the numbers are all the same there. We have the columns, we have the panels, the facet panels, which we're going to talk a lot about faceting. And yeah, so you can see that 14 and 17 are the same. And then we have these individual cell values, which end up not being analogous to the facet panels, but being analogous to a single bar in this case, because it's a bar chart, right? But this is the key. So now go ahead, Adrian. So now imagine if you're going to create the visualization on the left and someone told you that the first step was to manually subset all of the data for all of the different facets and then calculate the heights, right? No one is ever going to construct that visualization on the left that way. So why should we have to do it for tables, when tables, as we just saw, literally are just faceted data visualizations? And so in our tables, you don't have to. In our tables, you don't manually do any of that subsetting or any of those, you know, cell value derivations. The framework is actually going to take care of those for you. So go ahead, Adrian. And this comes back to this zeroth law that I said before, right? So like doing all those things, it's not like we couldn't, you know, figure out what the subset is for each of those different facets and then subset to those facets. You know, we can use group by, you know, with dplyr, and we could do it, but why should we have to? There's no reason that we should have to do that. And so we're not going to, right? We're going to let the computer do that because the computer doesn't get tired or bored and it doesn't think things are tedious. So go ahead. And then Adrian, you're going to take over for now for a bit.
Good. Yes. So now we're getting into R tables actually. So that was the conceptual part. We're now looking actually how to create an R table and what are the different components. And I think if you walk away with anything from this workshop, it's one. It's a framework that's based on facets. And the second thing is there's 4 components to an R table, to table generation. There's a data set, the input data set, which usually is a data frame or a table. Well, almost always is data frame and table. Then we will introduce a concept or an object called layout, which is something that defines the faceting and analysis, and it's pre-data. So you can do that. You can create those layouts without actually having the data. And then once you take the data and the layouts together, you can build the table object. And then the table object is what is in R, like when you make a print table. It's essentially that you can query, you can subset it. You work on the table object, you can prune, sort it, and so on. And when you print it, like when you make print of R table in your command line, or if you make render it to PDF or ASCII, then that's actually the format of the table. And so it's very important while you create tables that you keep those things separated. What is layout? What is a table object? When do you actually talk about printing? And of course, the formatting here then shows up in the formatted table, not the formatting instructions. And so on, not the data will be summarized in the table object, and you can somehow, and you can access those summaries from the table object. But as it is, those are the 4 components of an R table, of table generation R table. And to keep using those images for a while, because they're so fundamental, in order to create an actual table with cells and summaries and headers and row names, you take the layout, you take a data frame, you could say build table, and that returns your table object. And so if you do that, then if you print on the table object, it renders it here into an ASCII text string. There's other functions that we will show to you that renders it into RTF, PDF text. Our text is already here, but text file. And so to look at that all in action, so that's a very simple table. We call the library like the rtables package. Then we create the basic tables. We're going to talk more about that, that's essentially a start of a layout with one column with all patients, 0 row. Then we split the column space by the arm variable. So this is a variable name. And again, it's important, that's a variable name that needs to appear in the data, but there's no reference to the data. Only it's a promise that this variable should exist when you build the table, or a promise. We know about the data frame that we built the table from. We have the arm variable, and then we analyze the age variable, and we do that for every arm we calculate the mean of age, and we would like that mean is formatted as a number with 2 precision points and 2 precision digits. And so that then we call build table as seen before. We use that layout that was just defined, and we add the data that we have now, the data frame, and then we print it. And so if you here's the layout. here's the layout that we create. Then the layout is here again, where we use it. Then we use the data frame. That returns a table object, and if we print it, we get the formatted table. That seems fairly involved, but when you use rtable, it's all not that. It becomes second nature. So here you essentially see those components to load the library. You build, you define, you specify the layout, you build the table with the layout and data, and then you can print it, and you get that ASCII representation in your RStudio environment. And so that's the first exercise where I would like that everyone fires up RStudio for sure.
Yeah, just keep using the same environment that you've been using. But basically, when people clicked on Start Assignment, it replicated it at that point in time where the project was when you shared it.
Good. So I'm going to resume the project now, and then I'll walk you through the setup of RStudio, the way and of the project. So good. So what you will see is, do you also see exercise 1 opened? Gabe, do you see that? Oh.
So I'm getting our session disconnected.
Yeah, so that, I think, Gabe, you're trying to connect to the same session that Adrian is using. And so,
okay.
Yeah, so you'll just want to spawn your own, basically using the link that he shared.
Got it.
Yeah, yeah.
Yeah, so in appearance, so I'll make mine a little bit larger so that you see that. Good. So what you will see is RStudio, as you know, and most likely like it. But so I can make it larger. But so it's a default view. We have cloned the repository. You have access to the public repository with all the exercises. And some of them are called exercises. They're not, they're just a walkthrough. I mean, the exercise is working. We don't ask you to modify. Some of them actually have tasks that you do. And if they have a task that we ask you to do, Gabe, are you still using mine?
I'm not trying to, but I don't actually have a start.
So can I undo you from an admin?
Yeah,
so
go ahead.
Yeah, that's probably what it might be. A contributor.
I'll make again a contributor. Yes.
See if it, I don't know if it took there. You might want to do it one more time. There you go. Yeah.
Yeah, there we go. Is it working?
Yeah, it should be.
Yeah, so now I have a start button.
Yeah.
Okay, there you go.
Good. So now I have to find my assignment again. There we are. Good. So, yeah, so we clone the GitHub repository with all the exercises. It's if there is no solution to the exercise, then it's just a walkthrough, and we walk you through various steps of it. If you open exercise number 1, which I would like to focus on, we have installed all the packages, so please don't copy the code we shared in, we shared how to install it. Please don't do that. It's all already set up. It should all work. So if we look at this, and you also shouldn't see this because that's how I set it up. If you run this line by line, so you can make command or control enter, you do this. That's the simple table we showed before. You create the table, you print the table, you get the ASCII part. And something I haven't mentioned yet, if you make viewer, if you call viewer on table, it opens the viewer pane, and you can actually look at the table in HTML. And so I think that's, I mean, it's a fairly straightforward exercise. I just would like to see that everybody can create a project and can run that. So I'll wait maybe 5 minutes, 2 minutes, and then we move on with the presentation. So we go into each of those aspects later on. Right now, it's just important that you can run those.
Yeah, Phil, I am also seeing the thing that Bill had with.
Oh, okay. Every once in a while, you can see some things that are a little bit strange. Typically what I do when that happens, I just refresh the page and it seems to solve it. If it's something to do with the packages, then it might just be a message or a warning and not a blocking issue. So
did we not install the mock creator? Is that?
No, it's not. It's
Oh, we have it. We have it, yeah.
So if we, yeah, so it thinks that home, which is tilde, is this. So if you do normalized path of tilde in your terminal.
Mm-hmm.
So you have that, but the rest of us, when I run that, I get the same directory, but it doesn't exist. So
Phil, do you know? So it says that
so
the
occasionally,
home is,
yeah. So Bill had the same issue, and he just refreshed the page and it solved it. Sometimes when I teach workshops, I see a few things that are just a little bit strange, and typical local installations of R, you can sometimes work around them. Typically, what I just say here is to refresh the page and see if that solves it, because it can kind of clean out the engine and start things over. So if you see that, Gabe, or anybody else, try refreshing first, and then if it persists, then it might be something related to the packages. Yeah.
Good. So everyone says it works. Refreshing is a path to. So has anyone not been able to run this? Because otherwise we move on. I'm looking on the chat right now. If you have not been able to load RStudio Cloud and start an assignment, yes, okay, and run this code and see the viewer pane with table and the simple table here, then please let me know.
Looks
Yeah,
like
it looks like from the
people.
Yeah, the samples looks like you're good to go.
Yes, okay, good. I think one thing, because we don't go into detail here, I'll say it right now. You can also look with the RStudio viewer of the data frame at the data. It's synthetic data. There's no real patient behind that. We simulated that. It's from a package called random CDisk data.
And
you see,
and it's included this one. All of the X underscores are included in formatters. So you don't need random CDisk data to run this. That's just how we created what we ultimately then provide through formatters.
Good. So exercise 1 done. So then I'll pass the ball to Gabe, and you can.
Yeah. So now we're going to do this sort of end-to-end process of making what could be essentially a production demographics table, except as we just mentioned that the data is completely fake. But we're going to do all of the process for all of the sort of things that you would need for that, and then we will and so then we'll see sort of how the sort of basics and the conceptual stuff that Adrian and I just talked about fit within the actual work of creating a table with all the pieces that we need. So go ahead, Adrian.
That's the exercise.
So here's the exercise. So we're going to exercise 2 in the assignment here. So what we have is basically sort of skeleton code. And your assignment for this is to add title, subtitles, main footer, and provenance footer entries to this, and then look at what comes out once those things are added. So if you look through the code here, it should hopefully be pretty clear how to put each of those pieces in, because we sort of gave you the skeleton of all the calls. But go ahead and pick a fun title and subtitles for your fake study here. And then so just take a couple minutes to do that, and then run it and see how that changes what's ultimately rendered in ASCII once you print the table that has these things. All pieces that you can do yourself to keep you engaged. And then once this is all over, then your job will be to use it for the tables you need where you don't have the skeleton. But okay, I think it looks like a number of people are done. So Adrian, if you can just load up the solution. So as I'm sure most of you realized, right? Like the title goes in the title argument. The subtitles can, to be multiple things. It can be sort of multiple strings. And then the main footer. And then it looks like I accidentally deleted the hash part. So if you could put that back in, but yeah, so we added the file, and then we can still have our data hash. So then if we run that, we run all of that, and we can look at the table that gets printed out. We can see now it has all of these annotations. The table itself is the same as it would have been otherwise, but now you can see that our titles and our subtitles and our main footer and our provenance footer are all showing up, and they're encapsulating the tables. So our tables does support sort of these types of annotations of tables that you would need when you were actually putting them, into use. So that is that.
Yeah, I think 2 comments quick, because
Sure.
what you see right now is hopefully what you used. There's title, footnotes, there is the table body as a footnotes, yes, and rendered in ASCII. And so we're going to go over other formats than ASCII, but yes.
Yeah.
And yeah, and then the other thing I wanted to mention is that in title footnotes, every element of a vector is considered a paragraph. So if you resize it in the certain, like in the plots and so on, it will break it as if this were a paragraph.
Right.
So one title, multiple footnote. I think it's in the documentation. There's multiple provenance footers and one main footer, I think.
You can have multiple footers, main footers,
Okay.
if you want. We just only had one here. But yeah, everything's
Good.
allowed to. I think even title is allowed to have multiple values if you want. Although I think usually people wouldn't want that. You'd usually have one main title, and then everything under that would be subtitles.
And then
yeah.
also if you well, actually it doesn't here, yes, but in other text, if you copy that out and you would make it smaller, it would line wrap it. If you get into that problem, just make viewer
Yeah,
table.
So the line wrapping is a little bit the line wrapping is an argument. The line wrapping needs to have the concept of a width, and that's something that you have when you're defining pages. So we'll see when we're rendering to pages, like to things that have pages like PDF or RTF. I believe that line wrapping is turned on by default then, and if not, we can show you how to turn it on. But when you're just printing to the console, it currently doesn't pay attention to the console's width, which is why that wrapping is not happening here. But we can talk if people have questions about that, we can talk about that in a bit.
Good. So yeah.
Right.
That's
so good. Just as we were just talking about word wrapping and size and things, I'm sure everyone who's dealt with real tables knows that some of them are big, right? And in particular, some of them are bigger than the paper that you are ultimately being asked to print them on. So that means we need pagination. So if you go to the next slide.
Yeah, one moment, somebody's asking about the RStudio link, so I'm trying to copy this quick. Give me a second. There we are. So, yeah. Did
Right.
that work?
So this.
Oh, one moment. That's some apologies. How do I go back? Good. There we are. Good.
Yeah. So here's our table here, right? And then the team lead for your trial says, okay, now we need to print it out, right? And so here's our page. Obviously, it's not going to work out. So what we actually need, we need multiple pages, and it's important to note here that at least in some occasions, we need multiple pages in both the horizontal and vertical directions, right? So the most standard thing is to have only vertical pagination, where you have a page and then another pages on top of it. But sometimes, even when you have landscape, orientation of your paper, your table is just too wide. So you actually need pagination horizontally in addition to pagination vertically, and rtables supports that. In addition, next slide, please. Yeah. So in addition, the other thing that rtables is going to do that sort of just truncation and chopping things up wouldn't do is that rows that provide context will be repeated after pagination. And so what that ends up meaning is that when you're going from page to page, it's much easier to understand what is at the top of the second page. So we support that as well, and we're going to see that in action in just a moment. But first, let's talk a little bit about what gets repeated and what doesn't get repeated. So here we have sort of everything that is sort of part of the larger annotated table object once it's rendered. And we note here that page numbers, just to be upfront, we don't have, but they are coming. But the rest of these things are all already implemented, as we saw in the example. So we have titles and subtitles and global footer and provenance footer, and these are on every page. So regardless of whether you're paginating horizontally or vertically, your titles and your title materials are going to appear on every page. You have page titles, which I don't actually think we get a chance to talk about in this talk, but if people have questions, they can ask. But we also have the ability to paginate by values of a variable. And you see that, I think, a lot of the time in lab readout tables. And those are going to not be repeated, or rather, though, they're not repeated on every page. They could be repeated if there's further pagination underneath them. But if they are the level of pagination that's happening, then they're not repeated anywhere. And then you have the column structure and row structure, and those are repeated. The column structure is repeated, when you're vertically paginating, and row structure is repeated when you're horizontally paginating. But they're not, each row will not be on every single page, and each column will not be on every single page, assuming you have multiple pages in both directions. And then we have something called referential footnotes. So these are the sort of like, one, and then the one is, this thing didn't converge or whatever, right? That's what we call a referential footnote in the rtables framework, as opposed to footer, which is just text that goes at the bottom. This is something that refers to either a column or a row or a cell within the table. And those are not repeated. Those only go when the cell is, or when the thing they're referring to is on screen, is on the is being rendered. And then the page footer is the same as the page titles. So, and then the cells, it depends, right? Because we just talked about how, some summary cells, context cells are repeated. And we'll talk much more about what these summary cells are later in the talk. But those will be repeated for context, but sort of basic analysis cells won't. And this will be more clear once we've talked about what each of those types of cells are, which will happen later in the talk. So go ahead, Adrian.
Let me see. So there we are.
Yeah. Right. So as we said, we support pagination. Pagination is built into the formal exporter. So export as TXT, export as PDF, and export as RTF. It's not built into the exporters where they're going to like HTML, which doesn't really have the concept of like a physical piece of paper, but like all the ones that are modeled off of physical pieces of paper, they have pagination built into the exporter machinery, which is both horizontal and vertical. We allow for page and font size specification, so you can tell it how big you're going to print it, the text, and you can tell it how big the page is. And so we automatically repeat rows that provide context. So those are labels and summaries. And then we have this word wrapping of the title and footer text. Word wrapping of column labels is coming, but not in yet. That is we are actively working on that as well. So that is that. This is just an illustration of all the different things that you can specify when you're paginating a table. So you can see you've got page type letter. So we support just names of like a few different page specifications. So letter, A1, I think legal, or A4, I think, and maybe a couple of others. You can specify a font, although it will refuse to do it if the font is not monospaced. We don't support non-monospace fonts because it means that things wouldn't line up properly. Whether or not your landscape, you can also not specify page type and manually specify page width and page height in inches. You can specify the margins, and then LPP is lines per page and CPP is columns per page. So that even overrides the physical dimensions. And then you have things like how many siblings do there need to be on both sides of a pagination break before it's considered valid? So like we won't paginate right before the very last sibling by default, although you can see that's an argument that you can specify. You can tell it that you don't want to break in certain things. And then TFREF, that's to turn on the title footer wrapping. Go ahead, Adrian. So, all right. So now we're going to paginate our demographic table.
It's a simplified demographic tables for the books. we show the full demographic later, but yes.
Yeah. Well, we show the disposition table later. That's different than demographics, right?
How did that get missed? I'm sorry. So this should be 02_exercise. So if you could change the source.
Yeah. Or, I mean, you probably don't need the source because you're in the same session, but you still have table.
So when you print out the table, you should get your, actually it would be nice.
Yeah, you should actually do solution, not exercise.
Take the solution, yeah, solution. So if you can change this to source 02 solution, and if you print the table, you get title, footnote, you get everything.
Yep.
And as mentioned, we are aware that this is not the full demographics table, but we get to that later.
And then, yeah, so then you call paginate. Or actually, so this is you have to specify, like this is the exercise, right? So your job here is to specify a page type and a font size. And then once you do that, then that call will work. You can also specify that you want landscape orientation instead. And yeah, that. So go ahead and do that. And then you'll be able to see these paginated tables.
So this is table. You can say A4 font size 8 when you do this.
Yeah.
Let me make the font smaller so you can explain what's going on here.
Yeah.
I make it H so see it visually.
So this was too big. So make the font size 12 for me. So now run. There we go. Now we have pagination. So 8 was small enough that we didn't actually need to paginate. And it will tell you, it can tell that, and it will be like, okay, I'm done paginating. Here's your table back, right?
But we triggered a horizontal pagination. Let's see if we can make just a vertical pagination. That's interesting.
So if you do it, if you run the one with landscape, I think that one
yes.
8 with landscape,
yes.
I think does.
Yes,
Yeah,
that's good.
There we go. So this is one where, so you can see, first off, can you make the text of RStudio a little bit bigger, Adrian? Because it's a little hard to read, I think. Thank you. And so, yeah, so if we sort of make the console part big, so what's going on here? So you can see that we've got the titles. The titles are being repeated, and then we've got part of the table. And then if we scroll down, the table ends there. Unfortunately, it's not ending in the middle of a thing. But then we have the titles again, because we have this is a new page, right? This is the part of the table that gets printed on a new piece of paper. And then it starts again, and then it keeps going until it is done, until it's the end, right? So
and 2 comments here is that the column widths don't match up. You can do that if you need that. They will match up if you export them.
Yeah, the exporters ensure that the column widths match up. And so everything will be physically aligned on the pieces of paper that you're printing it on. Okay.
Yes, and so the other thing I think that Gabe has mentioned with the siblings. So, for example, in country, you wouldn't want that country China would be alone at the end of a page. So you can say, how many do you at least need per page? And then he breaks it. If it were here, let's say here the page ends here, then on the next page it would start with country and then PA key.
Country is one of those things that I talked about that provides context, right? So country tells us what PAK means, right? If you just say PAK, I don't know. But if you say country PAK, then I know that's Pakistan, right? And so that's why when we were designing pagination, it was very important that we reprint these context queue rows. And that is what pagination will do. So you don't have to worry about figuring out how to get it to do that yourself and like keeping track of row indices or anything. We do all of that for you in the pagination machinery. Okay, so let's go ahead and
do it.
Right. So this next one is basically going to be the same thing. Right. So that's a feature. Yeah. That's a feature that is coming. So you could force it. You could force it to do it now by adding it to a page title, but we will be adding page numbers soon. So so right now you'd have to like sort of hack it in there, but in the future, in hopefully the next CRAN release, you should be able to get page numbers on there.
Good. So
now we're going to render this table into so Kamal, the answer to your question. So ptables 2 is it's a list. It's a list of table subsets. So I don't know what viewer would do with a list of table subsets, to be honest, but you could do ptables 2 bracket 1 and do that in viewer, and then you would see a viewer of the first page.
So ptables. And then you get that.
And then you get the first one.
And a little sneak peek, you can also make ptables 2. You can get more than one, but that's here not so not so meaningful because you plot it next to each other. So you can have more than one, but then it's kind of
That will be, but you can see here
for comparison. Yes.
So you can see here that horizontal pagination has happened, right? Because it's not, the rows are all the same, but the columns are different, right? So only drug A and drug B fit on the first column, on the first page. And so drugs, the combination and the all patients columns had to be paginated to the second page. So that's horizontal pagination in action.
Yes, it's actually good we did that thing to see it. But we are aware that would not be going to the health authority this way, but it's just to show that this is happening right now. So
Right.
1, 2, 3, 4. But so
now we're going to render.
Exactly.
So as I mentioned, the rendering, so yeah, what I'm calling printable page type exporters have the pagination machinery baked into them. So all of the things that you can specify for paginate table, you can specify directly to each of these export functions, and it will go ahead and do those for you.
So if you run this, it will give you the that file text output here. You can click on this, and you see the.
Yep, and there's our break. You passed it. There's our break, and there's the titles again, right? So you can see, and you can see that page break is something that we specified, so that can be whenever. Yes, Siam, we do have RTF output. That's one of those things that is a reason that we're using the version on GitHub, because I just added it and it will be going into the next version on CRAN, but it is not on the current version on CRAN, but it is in. So if you scroll down, Adrian.
One moment, quick. This one is important. The second one, because they have the RTF. Oh, and here you see the wrapping. No, you just have to make it larger because it's a text file.
Well, that was soft wrapping.
That's soft wrapping, exactly. But this is what you would submit to the health authority if you were working at Roche. For other companies, it's RTF, or PDF, and so we're going to show that in a minute. And so this separator you can choose. That depends on how you downstream process it.
Yep.
So
next
let's make
is
just the landscape. The landscape is the one that's important.
Yep.
So this PDF.
Yep.
I think I can open it. There we are.
There you go. And you can see that they're landscape pages. You can tell in the viewer that they're landscape pages, and that each of the pages has the title and footer information on it, as we intended and expected. So, and here we have the repeated thing. So country, so countries goes down to Japan on the first page, but that's not all of the countries. So if you go to page 2, so it goes down to Japan, and then it's like, I don't have any more room. So then it says, now there's more countries. So I'm going to remind you that these are countries. And then I'm going to say GBR and CAN and CHE, right? So that is PDFs. You can see that the PDF just contains the ASCII like output within a like PDF file. Like the text is identical to the ASCII output text. Except it has things like, margins in the PDF and things like that. And then if we go down to the RTF, it's the same. I don't know if we actually have an RTF viewer, but I think
unfortunately not.
But this is an RTF file. This one actually is a little bit different than the PDF, because this is actually output as a table object in RTF. It's not raw ASCII text the way that it is for the PDF. So so that is all you have to do to make an RTF output with rtables. We use R2RTF under the hood currently. That may change to either having the option or just using GT in the future, but GT's RTF exporter didn't work for us immediately. So, but yeah, but the API that you're using from rtables won't change regardless of what backend RTF thing we're using. So the bottom line is rtables supports RTF export.
And so it would be great because I think neither Gabe or I do have Microsoft Word. We tried it with other viewers. But if you have Microsoft Word, please give us feedback how it renders, if it renders well.
So I've been testing it in LibreOffice, which it is rendering correctly. So as far as I can tell, these are valid RTFs. Oh, looks like we had someone that does have that, and it looks good. So great. Thank you, Amy.
Yes. And so someone asked, add overall level generates total column. Yes, we get to that in a moment.
Yes. But yes, that is what that's doing. And we will talk more about how to do that. Great. Thanks, Jeff.
Good. So I think this is the end to end. I think this is 1 hour now over. I hope that was useful to show you how quickly you can go to make a table that is production ready. And so the rest of the course will focus on various aspects of the table generation. So if you stick in this course, which we hope you do, you will learn advanced topics of how to create R tables and how to manipulate R tables and how to get our table display what you intended to display. But
basically now we're gonna show you how to make a table that isn't the most basic submission table, which is demographics, right?
Yes. But I think this is a good time to make a 5-minute break. So if you make every hour a 5-minute break, that people can go and grab something to drink.
Sounds great.
Maybe play a little bit more if you don't want. I mean, with the files we've given you, with the exercises, and then so we return in 13 after 11 in 5 minutes.
Sounds great. Thanks, everyone. And I will get those blank lines working if they are not already working.
Good. So the break is over. We continue with the workshop. And so where you have seen something that looks like a demographic, it wasn't completely demographic. And we actually show later how to make with pure R tables, a demographic table. But there is also a package from Roche that, which is called Turn, that uses R tables to create most of the standard clinical trial tables. And in fact, I think to my knowledge, almost all, over 200 standard tables have been created using R tables and Turn. And so Turn is on top of R tables. It doesn't create the table by itself. It uses R tables like basic table and split calls by is from R table functions. And then what Turn adds in the demographics example is a summarize was function, which essentially extends the layout. And if you do that, so that's the next exercise, a very short one, exercise 5. You see here R tables Turn. You can run that. We get the variables. This time we also get the variable labels because it's an argument here. So there's a difference between the variable name and the variable label as defined by CDisk. If you get the variable labels, they look like this here. So
that does also work in base R tables.
It also works in base R tables. Yeah. We show that
var labels. The var labels argument is also accepted by analyze.
Yeah, we show that later. But so summarize var is a term function if you run it from the term namespace. And if you run that and you look at that table, now we are much closer, or we have a standard demographic table layout. Oh, yeah, so there's actually a good thing. So here, if you want overall, you can make first false. Add that here if you would like to. If you do that, then you have a standard demographics table with an overall patient, overall column. You have the number of non-missing. I think that data set definitely has any missing. The N is missing.
Yeah, it doesn't have any. It doesn't have any missing.
Yes, it doesn't have any missing, but you have the mean, standard deviation, median, range for continuous variables, and you have also the non-missing number of data entries for gender here, and then you have a table, essentially count and percentage for the patients that fall into a particular facet.
And these are in column percentages, not overall percentages.
Yes, so
right.
Per column. So I think what's also missing here to be it's show column counts, and we show that later, to be completely done. If you add the show column counts, make first equal false, you get something that now it looks like the real deal, and so that's hopefully shows how quick you can create fairly involved tables with rtables, and how expressive the syntax is. Good, so you can run that exercise. That's just to mention you can use rtables alone. You can also look into Tern. Tern gives you certain things, but everything you can do with Tern, you can do with rtable, and knowing how the rtables framework works.
Yes, we will be covering this later, Shengwei, but you have full absolute control over every piece, essentially, including exactly what tabulation is done. So you could easily add in quartile range. You can change, how many decimal places are printed once it's rendered. Like all of these things are things that we will be showing you how to control over the course of this this training.
Good. So this is kind of so I think this completely now wraps up how quickly you can get to production, like to essentially publishable table. Now we will iterate over every aspect again and give quite a bit more insight. And some of them we move quicker so that we can make a good coverage of all the topics. But those slides are online, the exercises are online, so you can pick up the things we are skipping yourself. We also plan to then eventually move some of the documentation in here to the actual, to the two vignettes. There's already lots of documentation in rtables, but this is the first time that we have something in that form of a training. So what's next is we look at the various aspects of layouts and layout generation, facet specification, and then how you can create quite a bit more advanced tables than what we've seen with the demographics table. It's okay. Go ahead.
Right. So, so as we talked about in the beginning, when I was talking about sort of the conceptual foundation of our tables, layouts declare table structure before data is present, and then they are applied to data. And when a layout is applied to data via build table, a built table comes out, right? So layouts symbolically, like in terms of like variable names, declare what should go in the table, like how the table should behave. They declare the faceting structure, and they declare the cell value derivation. And then every layout begins with basic table, and basic table just says, I'm going to be making a table layout. Like I'm starting to describe a table structure. This is the beginning, right? Is basic table. So, and basic table, as we saw, takes a number of arguments like title and whether column count should be showed, arguments that are really sort of controlling overall information about the table.
So exercise 10 for basic layouts, we have an exercise for you. I think we skip ahead and show you the solution and discuss that quickly.
Yeah. Right. So basic table defines it defines a single facet in both row and column space. And the facet in column space, of course, results in a single column, which is the all observations. And the facet in row space, remember that facets in row space they don't correspond to cell values. Remember, cell value, if we think back to our bar chart, the cell values were the individual bars, where the facet was the that dimension of the subplots, right? And so our subplot doesn't have any bars in it, right, by default, because we haven't told it to put any in there. There it is. Yeah. So
the facet is one element of the grid which corresponds to a subset of the data.
Right. And so faceting in the row space is, the Y dimension of this grid, right? It's the, adult male, child female, child male. And so we have one facet, but we have no cell derivation, so we have no cells, and so that ultimately ends up being a table with one column and no rows. And that's if you just do basic table. So next we're going to talk about how you declare cell value derivation, how you declare what is going to go into my table, right? What are the cells going to be? And we do that via analyze. So analyze takes the name of a variable in its most basic form, and then it does some sort of default behavior for that. And the default behavior for a numeric variable is to take the mean. But you can see here, we can also specify our own analyze function, which does this 5-number summary, which we like, right? So as with essentially everything in our tables, we can fully override and customize the cell derivation behavior by providing an analyze function, what's called an analyze function. It does have defaults, and the defaults I think are pretty sensible, but we can also specify our own. And here we're specifying the 5-number summary. We're also specifying some formats in there. We saw the formats briefly earlier. And then we say, okay, use this instead of your default. And it says, okay, I'm going to make, instead of one, remember this is the equivalent, the top one is the equivalent of one bar, a bar chart with one bar in it. And the bottom one is the equivalent of a bar chart with 4 bars in it. Remember, these are not facets. These are elements of the plot, right? The individual bars in the analogy that we're using. Okay. So that's analyze. And that's how we can fully control. And this is how you would do the thing that was asked about, adding the interquartile range, right? So I did something different. I did, mean and standard deviation. Notice those are together. It's a single cell with 2 values. This is another thing that rtables has absolutely no problem with. But you could have another line right here that said, IQR, and you just calculate the IQR for that, or Q1 and Q3 could be either a single 2-valued cell or 2 separate cells, right? You can do anything you want. You can do, and rtables will be happy to just render that out to a page. So
yeah, yes, and two comments for questions. Missing, that's a good. How are missing data handled? It depends. So in the analyze functions, you need to handle it now. Like if you give a missing data in here, mean gives an NA. So it's your responsibility in the analyze. In the split functions, I think, Gabe,
the split functions, they're omitted.
They're omitted, but when does it cause an error? Because it caused an error in the demographics table. I think that comes from the analyze function, that error. So we would have to fix the analyze function at that point, or modify it.
But yeah, so typically if you're splitting by a variable and it has NAs, you will not get a facet for the NA values. They will be omitted. In the analyze, if you're analyzing, as Adrian said, you will get the NAs, and you can turn on, I believe, you can turn on the splitting to say, no, I really want NAs. But yeah, so that is that. So go ahead.
Good. So let's do exercise 2, and how it compares to table 1. It's, you will see in the remainder of this
right.
of this workshop. But it provides the table generation in a very succinct and sophisticated way. Where I think table 1 you need to use dplyr.
Right. This is the whole, like, you wouldn't ever manually calculate things that are going into different facets of a ggplot, right? You don't have to do that for tables now if you use rtables. Whereas if you use one of the other sort of dplyr plus solutions, then it's your job and you have to actually do all of these things. So you would have to apply this 5-number summary to each of the subsets that correspond to each of your facets. Now, right now, there's only one facet, so that wouldn't be that bad. But we're going to see later that the faceting structure can actually get quite complicated. And then it's not something that you're going to want to do. Also, I can say that, Adrian and I are both part of the regulatory table, our tables for regulatory submission, our consortium working group, and we're working on a book and the book has various tables implemented in a number of systems, and the rtables code is generally substantially less than half as long, and much less complicated than the dplyr code for some of these production non-trivial tables.
Yes, we also have a vignette on that. Good. So let's move on with cell value derivation, the second part of it. So we get back to cell value derivation. So now you have seen how you can create one or more values. Like the cell value can be any dimension, but then you can make multiple cells, and that gives either a group of cells that ends up into different rows for the same facet, or a single row. The next thing I would like to focus on here is to show how we can format, how we can modify your format, and how in rows can be used for both for collecting cell values and for doing somebody's asking for collecting cell values for multiple rows, and then how to format that. And so I'll go over this. You can run while I'm like this. We don't make an exercise. You can run while I show it here. But so generally, when you create a cell, you can use the rcell function. That's kind of the lowest level control over an individual cell. And so you say, you take your data in for the facet from the h variable. So for every column, which is only one, you take x will be essentially the h variable. So here it's the same as example ADSL h will be x. We take the mean, and then the format, we say we want 3 precision. If you do this, you get what you would expect. So here we set 3 color places. Then the second thing is you can have more than one value. So an rcell is like a wrapper over any data structure. Now, if you use vectors, you can use our 2-dimensional format labels. And so you can actually look what are all the format labels that we support from in our tables, because format labels are something fairly nice, which you will see later, to work with. We can use them in table shells and they make it quite visual what we want, but you can also have custom ones. So if you do that, now we have two values, the minimum and the maximum. We can also use range, and we have a two-dimensional format label. If you want to use as printf, you're welcome to do so. So here I'm showing how you can make an R cell also with minimum, maximum, and use as printf, 2 comma places floats, and now you have the brackets here. Yeah, so that's kind of format and formula label. R cell is the most specific way to say how a cell value should be visualized. Now, if you have multiple cell values, it's good to use it. I mean, you have to, if you have multiple value cells per facet, then use in rows, because every cell will show up in a different row. So use in rows. And again, you could use R cell if you name it here, which you should. That will show up in the tree that you see later. But so the important piece here is, again, you can use in rows, you can use the R cell, and if you build the table, you get this here. So now I say for H, for the we have number of non-missing, mean standard deviation, median, and range. You can separate the number derivation from the annotation, because this here is kind of an annotation formatting. So you can do, I mean, this is also annotation, but you can separate it from the formatting with a function. So for example, if you run summary 2 on H, you just get the numbers, you get a named list with the numbers, and then you can say, well, I would like to take those numbers and now put them in rows. And now you see another way how to define the formats. You can say, I'll take only the named list with numbers, and then for each element in this list, I would like to have this format. So if you do this, you see now our H variable has been summarized this way, and then you can use a summary 2 in analyze to make it simpler and reusable. If you build this, you see exactly the same as before. But so those are different variations to get to the same goal, and they show you where you can place in your format labels, how the format labels are specified, how you can create your custom format label with sprintf labels. Yeah, different ways of cell value formatting, and good. And then 2 things also to mention before we go to more different layout topics and analysis, that those analyze calls can be called sequentially, or they can be you can specify multiple variables per analyze calls, and then the analysis gets repeated. Or if you give a list of functions, analysis functions, it does the same as sequential. And then I'm going to show that sequential analyze calls. So exercise 8, which I just walk through the code and talk through it. You can do that as well. You can do it later to move on. But so a summary 2 is very similar as before. It's a formatted annotated analysis. If you run that, you get that row graphical section. And so what I also do is I create an annotated list. So a table. So if you have I take the table, gives me the frequency counts. I annotate that with, it takes by default the names, which is row name is the factor levels. And so if I make essentially a basic table and I split it by the arm variable, then I can analyze by age, and you have seen that before. That would give you just a single row. Not a single row, it gives you a single facet for each column, because you have multiple rows. So if I call that again, then with the biomarker variable, which is also continuous, you get this table. So that shows if you call analyze sequentially, it does what you intuitively, I think, makes sense, or what you probably expect. If you would like to have now, for example, gender, you would have a frequency table because that's a categorical variable. You can use that function, a frequency table, and it gives you this frequency table. I didn't add the lowercase n, you can add that fairly simple. What you can do is, so now we have 3 times analyze, we have that table as you see right now, because age and biomarker are both continuous, you can just create a vector here, give multiple variables on the same on the same analysis function, and it does exactly the same, so that they're equivalent. But what you can also do is you can actually give all the variables and give a list of analysis functions. So if you do that, so essentially that for age, it will take this analysis function. For biomarker, it will take the A summary 2. For gender, it will take the frequency table. When it builds the table, if you do that exactly the same table, what you can also do, I mean, those are just different ways to achieve the same thing. You can create the new summary function, and you essentially say, well, if it's a factor, I'm making an annotated frequency table. If it's if it's not a factor, we assume it's continuous. I use my A summary 2. If you do that, now you can use 3 variables and 1 analysis function. So there's lots of flexibility for you to get to the same table and then reuse components of the analysis. There's an exercise to add the n for the frequency table. We have the solution. I think it's, we'll move on. Yes. So Gabe, go ahead. Yeah.
Right. So in addition to what we just saw, sometimes the things that you need to calculate require essentially information about where you are in the tree structure, or in the table structure, right? Like what? Sure. And so that information is optionally passed to your analysis functions if they are defined so that they accept these various additional arguments. So if you think that you're going to need the column total, you just make your analysis function accept dot capital N underscore call. And that ultimately that gives you the total for the column you're in, and so that allows you to, for example, calculate percentages out of the column total within your analysis function. You can also get a number of other things. The SPL context actually gives you a large amount of information about exactly the faceting steps that took to get there, and you can end up doing very sort of subtle things with that, but that, as the arrow is informing us, is something that you won't generally need to do that, and it is a much more advanced usage. And for the full list of things that Analyze can accept, in addition to just the data, see the documentation for the Analyze function, where I lay out each of those and what they mean and what they do. So go ahead. So here we're going to use this. So we have an A fun, and now our A fun, in addition to accepting X, is also accepting this .n call. And now we have the column total, and now we're able to calculate a column percentage, which in this case is 100% because we don't have any faceting right now. But if we did have faceting, we would still have the full column total. So we would still be able to calculate the percentage out of the entire column within each of those facets. So that's that. This again is, I think probably
I think we can skip over it
because we just showed them the code for that.
We just showed.
Okay, so now we get to the other sort of really big part of this, which is we've talked about how to declare sort of cell value derivations, but we've been making this big deal about how tables are faceted data visualizations, and we haven't talked about how to declare facets. So now we're going to do that. So you do that via the split rows by and split columns by functions. You can think of these as verbs in the dplyr sense, even though obviously the names of the functions are multiple words, but these behave as verbs in like the same way as dplyr verbs do. And much like in ggplot, when you have that should say facet grid, not face grid, but that's a typo. But when you have that, you declare the faceting in rows and columns independently, and we do the same thing. So we have functions that declare faceting in row space, and we have functions that declare faceting in column space, and you can call each of them, and they're not going to interfere with each other, but they combine, just like in ggplot2, to ultimately create the full grid of faceting that you want. So go ahead, Adrian. So this is, I know I'm sounding like a sort of broken record here, but you know, this is the same as in ggplot. If you know how to use ggplot to make faceted data visualizations, then you know how to think about these tables within the rtables framework, right? So here we have a column faceting in ggplot and in rtables, and they're the same, right? So we split calls by arm. Facet grid calls is arm. Okay, so next. Now it's rows. Rows equals vars arm. Split rows by that's a typo. The picture is from that when that says sex. So we have, because you can see F, M, U, and undifferentiated there. So we have a faceted plot where the row facets are the values of the sex variable. And then we have the exact same thing with a table. Again, this is exactly the same. So go ahead. And now we have both. We have rows and columns faceting, which defines a grid. And again, we have exactly the same thing in rtables. This is not anything new or scary. It's exactly what you've already been doing with ggplot, right? It's just think of it as a ggplot where the geomes are rendering text, and you're 90% of the way there. Now there are some things that you can do in rtables that aren't easy to do in ggplot that we'll talk about later. But that's the core idea here, and that, to answer the question that was in the chat earlier, is why rtables is more powerful than a number of the other table systems, is because we are leveraging the same thing that ggplot is leveraging in terms of these in terms of the faceting, in terms of these sort of geome stat combinations and things like that. So go ahead.
We skipped that, I think.
Sure.
Because it's the same code as we've just shown.
It's the same code. And just like in ggplot, faceting can be nested, right? You can specify two variables, and when you specify two variables, it nests the faceting. It facets by one, and then within each of those facets, it facets by the second one. And this is something that ggplot facet grid supports, and it's also something that rtables supports out of the box, right? It's just the same thing again. Okay.
So we skip that as well. And so one quick thing when we show those tree structures visually, there are actual tree structures. So we have a little sneak peek into the table objects, so that you can see that we truly preserve that information of where things derived and what's the logical order of essentially nested splits. And to this one, I will quick run through the exercise. This is sneak peek. Now this is the table topic. We're still in layouts, but exercise 13. If we open this, there we are. So here I'm creating a new value, BH high low, where I make a high-low depending if the biomarker 1 value is above the its average or below. And so if you run that, so we split, we have a nested split here. In the column space, we don't have a nested split. In the row space, we have a single split, and then we analyze age. And because we're not interested in the cell value, I just return an empty string. So if I build that table, sorry, I have to print the table. It looks like this. So you actually see there's nested split. There is a single split, and the variable age is being analyzed. And so your question about here about what visibility means. Visibility gives you control, the visibility argument, what should be shown. Like you could hide that age if you want. But more importantly, in this context here, you can actually look at the dimension of the table. You can look like
it's sorry, 1 second, Adrian. It's actually the FMU and undifferentiated that you would be able to hide with show labels. The age is the row label, and the row label isn't hideable.
Yeah. Okay. I see. Yes. Yeah. Yeah. Correct. Because we actually give a row here back. I mean, you could set it to another
If you
value,
don't give the row a name, it names itself. It names itself by the function. But if the function is not a symbol, if it's just an anonymous function, then it names itself by the name of the variable.
Yeah. So if you would like to rename that, you would do it this way. But so sneak peek into the table object. There's lots of information. You can look at the dimension. You can look at like number column, number rows, but you can get into the tree structure of the table. We're not going to spend too much here, but everything has a path. So the column paths, there is variable arm, and then value arm like a drug X. Then this column like AL has variable a arm like then the value of the arm factor level, then variable BH1, and then the value of the factor level. And so you can actually path, we will see later, you can path into those tables and access the single values.
Yep.
And the same in row path, so those are for each of the rows. So if you look at the table here, now we have those rows, you see for each row, we do have a path, and the path are descriptive of how they were created. Variable sex, level female, then sex female, variable age, level AAR. Sorry, the analysis value AAA. And so when you create, so the message here mainly is when we show those trees, there are trees, and those will be very, very helpful later to do various things, and including pagination and cross checks between tables. There's lots of things you can do with that. We get later to that. Yep. Yes, and so the next thing then is when you, I think the next logical topic when you talk about those splits is, can you modify the splits? Not, do you always want a disjoint split of a factor, like with factorial variable into its different levels, or do you need other features? For example, like the overall column. Now, like in our tables, you don't have to stack the table on top of each other and say, well, these variables, these rows go into overall. You can define that by split with by split functions, and split functions are essentially saying when you make one of those. Sorry, when you're in root and you make a split, what data is associated to the facet? And so if you want an overall column, you give a split function that said add an overall level to your arm factor level. So no duplication of data is needed. That's very important, and that's also a reason why our table is so powerful. And so other things, like there's lots around level, like factors and factor levels. You can say drop if there's a level in your data, in your factor, that there's no observation, there's no instance of that level. Like so, for example, you filter by gender only females, and you will still have the male level and all the other one, new and undefined, unknown and undefined. You can use drop split level to remove those columns that don't have actual any values in them. We have certain ways of trimming. If there's no observation, you can use trim levels. And I think those are a little bit more advanced topics. We will leave that for you to explore. But essentially, if you would like to control how to get to the splits, you need to learn about split functions. And so I think I walk over those because those are it's very essential.
These are splits. The concept of split functions is very important to our tables.
Yes. So let's look at the very simple table we have before. It gives you 1 row, 3 columns. And so we look at drop split level. You see many of the split functions documented here. We document them in one documentation entry. So what we do next is say we would like to reorder the levels to placebo, arm A, and C combination. So now, right now, the level of arm, so EX ADSL arm, is a factor variable with 3 levels. We honor, like the rest of our most our base functions, all our base functions. The order of the level will be the order of how they are displayed in the table. So if we look at the table above again, if we don't do anything, it just takes exactly the same order. In the columns, if you want to reorder it, you can use a split function. So if we do this, now we have B, arm A, C. So reordering of columns, if you want to add an overall column, you can add split function add overall. We didn't have to change anything about the data. And that's really, really important. It's all a concept. Like it's all pre-data. It's declaring what you would like to do. And so here, by default, overall comes first. You can say first equal false in the add overall level, and it will move overall to the last column. You can rename it by, I think, do I do that next? You can rename it by giving it a label. You can say all patients here. If you do that, it says all patients. So you have lots of control with those split functions. If we now filter for only male and female and remove the undefined and unknown, then if you build that table, I can see something didn't. Moment, something went wrong here. Do you know what this is, Gabe?
Yeah, that's the correct
thing, because
right?
because I drop it here. So if you don't drop it, let me not drop it. Show you what happened. So yes, if you don't drop it, you get essentially all these NAs because we don't have observation here. Our table will still show the levels with no observation. So you can either manually drop it as we did here with X ADSL2 with drop level. Now, if you look at example ADSL2, this X variable, now it has only 2 levels because we did it manually. You get that table, but what you can also do.
Please scroll down.
I don't have it here. Sorry. So what you could also do is you could add the drop split level. So as X ADSL2. Apologies for confusing here. So if you do it here, if that's confusing here, you could essentially use here.
Not there. No, go leave that there. It goes in the next one.
Yes. Split function. Drop split levels. If you do this, then this is a function. Yes. It's a function. So if you do this and we use x ADSL2, then you will get the same. So you don't have to actually do it manually in the data set, which is, again, it's an advantage. If you run x ADSL2, if you don't do it, I didn't do the mutate. If you do it this way, you get everything. If you use that drop split levels in that split, you get also the minimum.
There we go.
And so that should show you how powerful those split functions are. And that's the more exercises you can do. I'll pass the ball to Gabe to move on to talk about custom split functions.
Right. So what we just saw was that you can specify a split function, right? And the split function is going to behave, it's going to control the faceting behavior. And we provide a number of powerful ones. But you can also define a completely custom faceting behavior. And what that ends up being is like you can write a function, and as long as it meets certain requirements, you can use that as your split function. And so really what we're describing here is we have generalized beyond the faceting behavior that like you would see in ggplot, right? Where ggplot, you facet based on variables, and then you get a partition of the data based on the variable. And that is the most common type of faceting in rtables as well. But we also support a number of types of faceting other than that. We saw the overall column, which is, if you think about it, the overall column means that faceting structure is no longer a partition, right? Because the data is in one of the columns and the overall column, right? They're not mutually exclusive. But we can do anything, like we can make it do anything we want. So go ahead, please. What that ultimately comes down to is there are essentially three things that a custom split function will be able to do for you. The first is it can modify data as it's incoming to the splitting process. So drop split levels does this. What drop split levels does is it receives the parent, like the parent data, the data that's going to be split up, and then it restricts the levels of whatever factor you're dealing with to the levels that you've to levels that are present, right? Like it drops levels that aren't observed, and then it just says, okay, now go on, now go continue, do the thing you were going to do anyway. So it's stepping in before the splitting process and just saying, get rid of the empty levels, we don't want them, right? And then the rest of the machinery just behaves normally. The second thing, which we're not going to talk about too much, is you could actually change what splitting even means. The only real constraint is that you have to spit out a list of data sets with corresponding values and labels and one other thing that's not super important. And then the final thing that you could do is you can post-process these sets of groups. So you can say, okay, what do you think the groups would be? Now I'm going to reorder them, or now I'm going to get rid of one of them that I don't like, or now I'm going to repeat one of them for some reason. And the helper function that we provide that's quite powerful, called add combo levels, does this. It does the normal splitting, and then it accepts a specification of level combinations that you want in addition to the normal levels, and then it adds those. It constructs those out of the group. So it says, okay, this is the data for group A, this is the data for group B. You've asked me for a combination of that. You've asked me for A and B. Okay, so I know A and know B. Put them together and you have A and B. And this is in fact, if you look at the code for add overall level, it's actually just calling add combo levels. It's adding a combination level where the combination is all of them. But you can restrict to not all of them, and you can have specific combinations in however many you want, and in whatever combinations you want. So go ahead, please. Right. So this is the real code for dot split levels. This is the actual implementation. And you can see there's that pre-processing that I was just talking about. Here we're saying, okay, we're going to refactor this. And what calling factor on something that's already a factor does is it drops levels that aren't observed. So that's just how factors work. And then we have this function. This is an internal function, but there's an exported one that you use in your own custom functions that we're going to see in a second. But then it says, okay, now go ahead. I'm done with messing with it. Now do the normal stuff. And then it comes out just like we just saw when Adrian was running it. So go ahead, please. So this is my extremely silly custom function. And the reason it's extremely silly is because we actually cover the vast majority of custom split types that you would need with the ones that we provide you. Like add combo levels is extremely powerful. It covers a very large percentage of the things that you would want to do. And there's another one called trim to map, which actually controls combination of factor values across multiple variables that are allowed, and it will trim everything down to just those combinations. And like between those two and like the drop stuff, you really don't need to do fully custom splits that often. But just to show you what it looks like, this is the exported version, this do base split. So that's exported, and you can call that in your own functions. And it says, okay, first do the normal split. Now I want the last one to be repeated again. So I want, arm A, arm B, arm C, arm C. For some reason, I've decided that that's what I want. And this is a custom split function that will give you that. And so you can see there it is at the bottom. We've got our duplicated column down here. Now again, you don't actually need to do this. It's a weird thing to do, but there are certain cases where you might actually want that. And if you do want it, here you go. There it is. Go ahead, please. Right. So the takeaway here is we are in control. We, the user, like our tables, I designed our tables to be extremely customizable. So basically anything that our tables is doing, you can probably tell it to do something else, right? You can tell it to do something else when you're doing analyze. This we saw earlier. You can tell it to do something else when you're doing faceting via these split functions. And the combination of those covers an extremely wide breadth of tables that you might possibly want to make. So go ahead, please. So here's our exercise. Do we have time to go through it or not?
I think we should move on.
Okay, so let's go ahead and move on. The exercise is just make it so that the first column is repeated instead of the last one. And we'll leave that to you to dig in and figure out what that is, how you do that.
Yes, I think so. That actually is the question that has been asked a couple of times.
Yeah.
How can you make the labels? Yeah, the labels. And so maybe let's move to this then. So that, because there's also a breakup coming.
Yeah, we're almost to the break. 71.
Yes. Okay. Okay. Yeah, that's good. Good.
Right. So there's various other things that you can tell layouts to do, right? One is we saw how to show the column counts. That's this argument to basic table. And the other main one, the one that has been asked about a couple of times, is this concept of names and labels. So in sort of base R, if you have a tibble or a data frame, you have row names, which are also row labels. They're also what's printed. So they're the same. In our tables, they are not the same. So the name is going to be the value of the variable that you're splitting on. And that's what's going to appear in the path. The label can be anything you want, and that's what will be printed. And by default, they're the same, right? By default, the label is the same as the value of the variable. But you can control that by giving the name of another variable, which has the human readable labels. And that argument is called label var in the split functions. And so you just say, you know, split calls by arm, label var equals arm CD, or the other way. I don't remember which one's supposed to be readable, but whichever one's supposed to be readable, you set that one to be var label var, the other one to be var, and that's it. And rtables takes care of the rest for you. So that's how you can control. You have the granularity of controlling what's printed without needing to modify the actual core data.
And so the reason this is particularly important in clinical trial, and why we do it because generally it's important, but when you make tables, there's lots of CDs controlled terminologies. You have dictionaries, like what are allowed values. You have controlled variable names. And so if you build a table correct, or if you build a table to a certain specification, then behind the scene, it's all the CD part, like the codes. And then you can change the visualization, like you can change how it displays. And the nice thing with this is when you actually go for cross-checking and do other pieces, like when you look back at the trees that those tables have, you always need the names, not the labels, for accessing elements and transforming the table or subsetting the table. And that's one very important reason. So in an optimal world, and I think Turn most of the time does that, your tables can look as you want. You could even internationalize them. You could make a different language for the labels, but the variables, like the actual indices and path, they use CD's control terminology.
Right.
And that's a very powerful thing to have. Good. I think, do you want to go to this, Gabe, or should we move on?
I think we should probably move on. There's example code and various points in the exercises for using this label var argument that I mentioned. So you can look around for that. I think we used it in the end-to-end example. No, we use it in the turn demographic example, but it also works in for base rtables. So let's go ahead and keep going.
Good. So multiple aspects here.
Right. So another thing. Right. So another thing is, most of the time, in my experience, the tables are going to be this faceted, like sort of traditionally faceted thing, where you have arm is defining your different columns, and then you have a body sys is defining your outer rows, and then your AE decod is the inner one, right, or whatever. But sometimes for certain types of tables, the columns are actually different variables, and you want to analyze each of those variables in a sort of columnar manner, and we support that. So you just do split calls by multivar, and then you specify the variables. And note that we know exactly how many facets there will be by default. You could override that and confuse it, but by default, because we're saying a certain number of variables, and that's how many columns there will be, right? That's how many facets at this stage of the faceting there will be. And then you use analyze call vars to specify your analysis function, and you can actually give it a list of analysis functions. So you can give it a different analysis function for each of these variables that you want to be a column. And you can see an example of that here, where I've just said, okay, so how many different ethnicities are present is the first column. That's my analysis of race. And then what's the average age, right? And so you can see my analyze call vars, the A fun is a list. The first one's applied to race. The second one's applied to age. And there you go. So that's that. And then I do think we should step through this one, because I make a note of nesting it inside other faceting, I think.
Should I go to solution?
Yeah. So, right. So yeah, if we run this, and then we print it, you can see that we now have, this works just like all the other analyzes, just like geomes. This works within faceting without being disrupted, right? So now we have for drug A and strata A, we have the count for how many unique ethnicities there were and an average age. And then we also have it for drug A, strata B, and we have it for drug B, strata A, right? And these are unrelated to each other, right? Like we do our analyze and we do our faceting. And the analyze and the faceting work together to make the table, but we can declare them independently. So we don't have to worry about what the faceting is going to be when we're constructing our analyze call vars. It doesn't matter, right? We have to worry about the specific multivar split, but that can be nested inside of other splits and nothing breaks and everything just works.
Good.
I don't know what you mean by stats as columns. I don't understand the question.
Yes, you can use that's model tables, model summary tables. So what you would do there is you would make essentially use Broom, make a data frame, and then
So you can do that. The way that you would, and then what would the rows be? Are rows different variables, or is this a table that only has one row?
different variables.
Different variables. So yes, you can do that. So what you would do is you would split the column. So you basically you'd split by something that gave you the columns that you want, and then you would do an analysis row. You do an analyze, and then you would give it a list, because I'm fairly certain that even in the non-call vars case, the analyze variable, the afun can be a list, and if it is a list, then it will be spread out across the columns. So that is how I would do that.
So generally, you would do that in row space, and we explained that that they're not transposable the table at the moment. But if you want, Gabe, you can write that code. I'm going to wrap up this section of
you go ahead and do that.
Then we can have another 5-minute break, and then we go into the last part of the table framework, where we kind of wrap it up all together. But so far, we've spent a lot of time on layouts for a very good reason, because it's really important to understand how we facet, how we can control those facets, how we can nest them, how essentially can get to the shape and the right subsets of data for your analysis. We showed how analysis can be performed, and I hope we showed that rtables is a very sophisticated end-to-end table framework. So the outputs we've created at the beginning of the workshop, they should be close, or they should be essentially publication ready. If not, please give us feedback. But I think that's probably, you should be able to read the code like this, know what we mean, what are formats, what are variables, how do we specify the facets, and then that there are layouts, data, and then the actual table objects. And so we do it the same way as before. We use 5 minutes for a break. You can use that to run through the exercise that we skipped. Go and grab a coffee. Gabe and I will stay here is a fine, Gabe, to answer questions. So we continue with the next slide at 12:23 my time. And so one question is about if you want to show F as female. Let's see if we can get that done right now here. So layout, basic table, split calls by the arm variable, analyze, no, split rows by text, and we analyze age with the mean. That's good enough. Build table, layout. Okay, so now this is obviously not what we want. Most of the time not. So if you look at actually the variable, so if you look at the two use object ID, this, okay, you get this, but more importantly, if you look in RStudio viewer, you actually see, yeah, so sorry. Yes, you see the variable labels. That's what I wanted to say. So essentially what you want to give levels to this. And so those dictionaries we don't have. So what you have to create is a data frame, not a dictionary for. Is that correct, Gabe? And then I need to make and then I think
no, you don't want a dictionary. You want a parallel vector. You want another vector in your data.
Vector. Yeah, named vector. Yes, yeah, true. With the arguments.
Labels var. So I was missing an S in my comment there. It's labels var.
And it's a named vector.
No, that would be like quote gender end quote, and then you need to create a gender column in your data.
Yeah, I see.
So here, let me.
So it's ADSL.
So yeah,
I know. Yes.
XADSL $gender. $gender.
Oh, yes, we can do that. Gender.
And then just female, male, like do the 4 values, and then you subset it with your factor, and you're done.
So it's case when, not case.
I mean, I guess.
Reply.
No, feather and arrow are both rectangular data frame specific. Actually, arrow might not be, but feather is. Our tables objects are not. They are rendered as rectangular tables, but they are not modeled that way internally. So you would not be able to model that. But at the same time, if you're not calculating the table, if you're just loading the table, these things aren't that big, and I'm skeptical that you would need to really worry about performance for just loading an RDA or an RDS file. I would actually need to see a table where RDS was actually slow enough to worry about before I worried about it. Even so, generating the tables is relatively performant as long as you don't have thousands of rows. But yeah, loading an existing table that's been serialized out should be pretty fast.
So you get those things from you get those from CDisk specification. I'm just typing it here. So you would do this. And I think that's also a more elegant way to do that. But yes, that's how it. Okay, so now if you look at gender, we should have exactly the full name. That's like param CD, and so this will be gender. And now you have your right labels. Okay. Does that make sense? That is that okay? So it's the same as param CD, arm CD. You have to create those labels, and then you can just give it as a variable name.
And the same thing works for split columns by. So you can control the labels in the column space as well as the labels in the row space. To answer this other question about the stats as columns, there's not a super easy way to do it. You can get rtables to do it, or I can get rtables to do that, but that is one use case that it's not particularly designed for. So it does take a little bit more work than everything else we're showing. But you ultimately can get a table like that out if you really need to. But generally we say, like, does it really need to be, columns? Because row, it's very straightforward to make rows that do that, and that it's the equivalent information. But you can, but it's difficult is the ultimate question, or the ultimate answer to that question.
And that's a good segue to the next topic. I mean, if you absolutely need it right an issue, and we can discuss it there. But there's a very good reason why we treat. There's a good reason why we treat rows and columns differently, and so that's what we're going to talk now. Before we do that, there's two topics. See, yeah, we moved this down. So before we go into
it's after the faceting now. Yeah,
it's fine. It's fine. So we have two topics more to cover. So if we quickly revisit and analyze, what happens is we know if you make split arm and split country only for US and Canada, we have 6 in row space. So in column space split by arm, in row space we split by country. We only have 2 country in this example here. We know we have 6 facets of some set of data. And we know that the analysis function takes the facet data in, like the subset of the data, and can spit out the cell. So if it spits out the cell, then essentially what the tabulation framework will do, it's going to create the cell for the first facet, it's going to for the second, third, not. It just iterates over every facet and creates the cell given the particular data. Now, if you return multiple cells with the in-rows object, then it does exactly the same. It gets more rows per facet. It gets 2 rows here per facet, but it goes over this every facet, and it creates those multiple cells, and they will be then arranged as rows. And that
just
is,
like
yes, go ahead.
Just like geomes and stats in a faceted ggplot.
Yes, it's exactly like it's very similar. It's similar to the same as ggplot. I'm going to skip this one. There's an exercise there that walks you through this, but I think this part is now, and Gabe will present it, shows how sophisticated the whole thinking of faceting is.
Right. So the one thing that's not super easy to do in ggplot is, and there are packages that will do certain aspects of this, but the marginal analyses. So you've got this 2 dimensions of faceting, right? And you maybe want an analysis on various parts of the facet. So rtables supports that. It has what are called row group summaries. And so what row group summaries are, so I alluded very early in the talk, right, to these summary rows, these rows that provide context that we want to repeat during pagination, right? And the most basic version of those are just the label rows, right? Like, you know, the female that we just put in there, which doesn't have any values. It's just a blank line after the label, right? So it's providing context. But you can also actually have summary content there, and we do that via these group summaries. So if you go ahead one, please, Adrian. So here we have an analyze, and we can see the tree, right? So the analyze is going to give us, you know, within each combination of arm, sex, arm across the top, and then sex and B1HL across the side. So we have nesting in the side. Within each of those, you're going to have our analyze, right? We've seen this a number of times. So go ahead, Adrian. Yeah, and again, as we talked about, Adrian just showed us that, you know, analyze can return multiple rows. So that square could actually be multiple, you know, cells stacked on top of each other. So go ahead, please. Right. So these are where the group summaries go. So you can imagine I want an overall summary. That would be a summary on the root. And then I want a summary for all the females. And then I want a summary for all the males, and then I want a summary for all the U's, and I want a summary for all the undifferentiateds, right? And then I want a summary for high within female, and low within female, and high within male, and low, et cetera, et cetera. So our tables can summarize or do marginal analyses essentially at each one of these levels, or any combination of these levels. So if you go ahead. So yeah, so these are the splits. The row splits are, this is a little bit misleading because one of the summaries is root, but the other two are these two row splits here. And root is always there, so you can always do that. But so now we say summarize row groups. And if we do that before any row splitting, that's a summary on the root. So it's on the full, like, parent facet that everything splits off of. So go ahead. And then if we do it after we split on sex, now we're summarizing each sex or each gender, right? Separately. So now we're getting, so that one call will give us a summary of the females, and a summary of the males, and a summary of the U's, and a summary of the undifferentiateds. And if you go two more to the next one that's highlighted. So now it's after B1HL. So now we're going to get the summary of the high and the summary of the low within each, separately, within each value of gender. So go ahead. This is what ultimately happens. So if we put all three in, then we're going to have summaries. So counts and percentages of the column total is the default behavior. But like analyze, you can make this do absolutely anything you want, which we'll see at the end. But the default is count percentage of column total. So we're going to have that overall. That's the root summary. Then we're going to have it for each gender. And then we're going to have it for each value, like high, low value within each gender. And we did all of that with just these three function calls within our layout declaration. Okay, so yeah, you have full control over what it does. You can do whatever you want.
And also you can change the whole summary. We just use the default one. So
yeah, the default one is the one I was describing, but it's just like an analysis function. You can write your own that does absolutely anything that you want it to do. You have access to the row group counts, you have access to the column counts, you have access to the total count, you have access to the counts from a previous level of summary. You have all of it. And so those summaries can be absolutely anything that you want them to be.
Like in the adverse events table, yeah.
Yeah, and we'll show you that at the end when we do an adverse events table, which we should make sure that we have time for. So we should probably keep moving.
I think that's how we should probably finish. Yeah, but the disposition. But yes, and that's one of the reasons. But so yes, I think we have time to walk through this exercise. I think this is an important one.
This is an important one. Yeah, for sure.
So I'll walk over it, and Gabe and I can talk over it. You can rerun it yourself later to get to the adverse events table exercise. So we create again XADSL3, where we just add another factor for if the biomarker is higher than average or lower. And so if you create that table, we make it fairly visual, that table. So in the analysis value, we just made a dash here. So all the analysis value are a dash, okay? And so if you add the first summarized group, it's essentially the root before the first row.
This is the root summary. So the overall summary.
You get at the root the
count and
percentage, which you would assume it's 100%.
Yeah, it's always going to be 100 for the root one because it's out
because
of
we don't have
the column.
Missing.
Yeah.
Oh, yeah, that's call, yes. So then, so you can fancy that up a little bit, but that's actually I don't want to show. It's not so important. So let's skip over this.
Yeah,
I thought I've changed that. So we put it in the second row, and now we see we have it essentially at every
gender.
Every gender.
Right. And these are no longer 100, right? Like, so these are out of. Can you do it? Can you run it one more time with the column count showing, just so that people can really see? Yeah. So now if we scroll up, we'll see, 79 is 59% of 134. And so it's doing all of that. That's the default behavior is this count percentage, and the percentage is out of the column counts. But again, as was asked, you can fully control this behavior. And so now we have it at the
let me add the show call counts.
The high-low level. Right, and this is why faceting is so nice. We only had to say this once, and it's going to be done for every single time that high and low appear in the table. Right? We don't have to worry about how many times that's going to be. We just say every time you have high or low, every time you're splitting on this variable, anywhere, in the row space, I want summaries, and then it just does it, right, automatically.
And so here I make a helper function just to say what type of summary it is. So we make a root summary, just a label, a sex summary, and a biomarker summary. And then I say the cell should show an A for an analysis cell. And and so you now see.
And can you also run it again with the default behavior?
Yes, I do have it, yes. But so it's the next one, yeah. But you see the pattern of what is a root summary, what is a sex summary, what is a biomarker summary, what is an analysis value. And so if we run that again with the default behavior.
Right. So now we have all of these, we have them simultaneously. We can watch the numbers going down. Right. 134 is all of them. And then there's 79 in F, and 79 is 42 plus 37, right?
Mm-hmm.
So those add up because there weren't any missing values. And that, so you can get all of that. And these are the things, these, just like label rows, as we saw, these things, these summary rows are repeated after pagination. So it would say, if you paginated between the L and the H, for example, then F would be repeated. So you would get, and I think the root would be repeated too. So you would get these.
I'm fixing
printed
here
again.
Now let's fix the roots here. I add the label, and now we have all. Just to show.
Yeah,
it's a little bit of work.
There we go. So that's group summaries.
again, like analysis functions, they can do whatever you want, but they have a sense that they have an even more sensible and they have a more applicable default than they now, because analysis could be anything, but like the summary, often what you want is just counts. And if you don't even have to specify what's called a content, we call it a content function, because it's summarizing content. But okay, so let's go ahead and keep things moving.
Because now we have all the tools. That's maybe
right.
The next.
So
So
now
the next
it's time to make some real
do,
tables.
Yes, and so that's everyone. We leave some time to actually walk you through and ask questions.
Right.
Because all of those concepts that we've just shown you, you are now able to create relatively quickly fairly advanced tables, which is the adverse events table and the disposition table.
Yeah.
So please go ahead to our studio, open exercise 20, and then let's first do 20, and then we go to 21. Do it, ask questions as you do it, and then we can discuss that, and then we go to the disposition.
Yep.
Post the shiny components that you can use in our table. Are there any questions to the adverse events table? Are you done, or can we walk over it, or? Okay.
Yeah.
So
so
somebody wrote down.
One person is completed. So why don't we walk through it? Since there weren't any things you guys had to do for this. It was just run the code and then look at it, and we can talk about the pieces in here that we've seen the vast majority of it. There's just a couple of arguments that we use that you haven't seen that we can highlight as we're going through.
Good. So this is random data. It's actually, we don't use the CD's control terminology or measure or any of. We made those up, so we make them here a little bit more readable. The body system, organ class, and then the code. So we just say it's a system, organ class, or it's a code for the adverse event. And then we create a summary function, and that would be group information from before. And we say essentially total number of patients with at least one adverse event. We can take, like, if X is U subject ID, then it would be length of unique of X, because you only want to count the U subject ID once. And again, we use the column N. And then total number of events is just the number of events here, the length of X, number of patients, not because patients are repeated in the adverse events data, ADAE. And so if you run that, you can always run as functions yourself. Now you kind of see what do you get outside of our table. When you create this, this is actually old. You shouldn't use this anymore. It's not legacy. Show code counts true. So you split by arm. You add all patients. You summarize use subject ID, because you make unique on use subject ID. So if you look at how many unique patients there are that have at least one adverse event, you run unique on it. So you use subject ID here. Then you split by body system, organ class. There's some label visibility setting, and indent mod is to move the tables around, because there's a logical structure, there's a structure that's visually logic, and we give you access so that we are indent mod.
And the reason you're doing the child labels specifically is because that controls whether the label row, the row with nothing in it, like the one that just said female, like previously, like this isn't sex, but like previously we were splitting on sex. So the label row that just said female, those by default are suppressed if you have a group summary, because the group summary typically will also have the name of the group in it. In this case, you can see it doesn't though. In this case, it has two rows, but neither of them say what group it's in. It just says it just says, number of patients with at least one, and then total number of events, right? And so we're saying, I still want those label rows also. That's what child labels equals visible means. Like I know that I have a group summary, but even so, I still want this thing that by default you would turn off, but I'm the user and I say that I want it on. So that's what's happening there.
Yes. So two group summaries, and then we get the terms, so the coded terms. We just make a frequency table. And so that, if you look at the complexity of what you do, you make two very simple analyses. For group summary, you make a frequency table of the terms. You use all basic R concepts, and you run that. There's one thing, because to get the right column counts, you need to give a data frame that has the use of subject IDs with the correct, not repeated use subject IDs. And so we use ADSL for that to get the column counts correct, because ADAE sometimes is missing patients. And
because the column counts are supposed to be patient, and ADAE is not a patient level data set, it's an event level data set, right? And so we need the counts to be patient counts. And so we can give another variable or another data frame, and it will do the same column splitting. And that's how it gets those ends. So it says, okay, this is the column splitting you've done. Now I'm going to do that same thing on this, what we call the alternate counts DF. And that's where I get my counts. But then for the table contents, I do it on the actual data that you said. So you can have these two sort of relational database style related tables, and then you get what you want. And that it's relatively common to need to do that, right? Because you need patient counts, but then you also need counts of, and we saw that our summary has both types of counts in it, right? Like it has an event count and it has a patient count. And the patient count is a % of all patients. It's not a % of events. So.
Yes, and so one thing, there's a little visual bug. So I think to move this one back, let's first look at the thing. So we have the root summary from here. Then we have the first system organ class from here level. That should be moved on back visually, so we can change the indent mod. Then we have the system organ class summary, which is from here. Same function as above, but now for every level, it's system organ class. And then we have the frequency table of the code. And we have lots of zero counts, and that's the next thing. But let's first try to fix that on the fly visually. That would be -1, is that correct?
If it was 1 before, it's probably just 0.
I tried that. Let me see.
0 is the default, so 0 is the same as not specifying it at all.
Yeah, that's not right here.
Okay, so -1.
-1, yes. -1. So this is essentially how you can make your table visually match what you expect.
There you go.
Yeah, there you go. So now you have total summary terms. Now, if you want to trim those 0 rows, there's a very simple function called trim 0 rows. And you get a condensed adverse event table where only terms get listed or codes get listed that actually have an observation for that subset of data or for that particular data.
Yep. And there are multiple ways to do that. You can also do that in the analysis function when you do the tabulate. You can also do it in the parent split. Like there's a number of different ways that you can get those zeros to not show up depending on exactly the behavior you want. But trim is one of them. So that's an example of this post-processing, this processing of an already constructed table to further refine it. So we should probably go pretty quickly because we want to say, so that's a relatively simple table, right? It's not as simple as the demographic table, but it's as adverse event tables go, it's relatively simple. So now what we're going to do is now we're going to do one that counts by grade per ID, right? So it's going to count the IDs at each grade, but only count them once, regardless of how many adverse events of that grade the patient experienced. So this is, if we just run this, we can see that I put the count at the top, and then we've got all adverse events, right? And this is our summary. That any grade through 5 is our that's all of those rows are our summary, our group summary. And then that's the level of our thing, and then it gets a summary, and then it it calculates, or no, sorry, those aren't summaries, those are analyses, the ones under the DCD, but the ones under the C's are summaries. So the any adverse event, and then it has a summary, and then if you scroll down, there's that C, that's the AE body cyst, that's the outer of the two splits, and so that gets another summary, that gets its own summary, and then it gets its children, which are the ones that have at least one adverse event. So
I've seen those tables where the any adverse event is a separate column. So for us, it's not a separate column because it actually is a split, as we've just shown.
Yeah.
We might look into just visually, but that's on the roadmap. We have to think about if we want to do that. I think if you look long enough at that table, it's quite intuitive as well. It's just different. Yeah, yep. I think we have 5 minutes more time. There is a disposition table, which is a good exercise. I'm not going over this right now.
What else? What do we should have? This is important. So if you have a defined, are you doing this one or am I doing this one?
Yeah, you can do it.
Okay, so if you have a defined layout that's just standard blank table, adverse event grade table or whatever, you can have that, and then you can apply it to each snapshot of your data just by using the same layout object if you have it serialized out, right? Like the layouts are reusable. And so it's very standard to have different snapshots of the same data set, right? Like I think everybody does that. And so it costs you zero extra effort to get the same table from a different snapshot. You just, well, I guess not zero because you have to find the data. But once you've found the data, there's nothing extra that you have to do. There's no massaging, there's nothing. You just pass a new data frame, the build table with the same layout, and you get a new table that you can then compare.
Good, and so that is relevant in clinical trials if you run the same table in different patient population. I'm going to skip over this. There's more topics for layouts. There's lots of documentation. We also skip over
layouts
this
are templates. Sorry, I was answering a question on that. But yes.
I will skip over this. It's documented here, though. You can make table shells, which is useful if you want to work with study teams and don't show data. And we are aware there's a small bug here. We're going to fix this. That it still shows in the end. I'm going to skip over all of those. There are 3 structures. Don't look at those 3 structures. You really need to. We just need to understand there are trees, and then you can access those tables. And I think we use that in pagination. It's relevant when you R bind, C bind. You can compare tables based on those 3 structures. There's many nice properties that come from the 3 structures. We have referential footnotes, which is a big topic. You can actually make footnotes from the cell that show up and then only show in the page where that cell actually is, which is...
This is also, you can see there's what's called a table inset here, where the title goes farther to the left than the body of the table. So that is something that you can also control. You saw that by default, it doesn't have that, but it's something that you can turn on to whatever level your medical writers might desire.
And the formatting we've discussed, and with that, we have 3 minutes left. We made it through,
so that,
through the end-to-end journey of our table.
That is our tables. So if you use our tables, we'd love to hear from you. If you're thinking about using our tables, if something doesn't seem to be working, please let us know and we will endeavor to fix it. You know, it's a public open source package, and so we have a public GitHub for it that you can file issues on that I respond to. And yeah, like hopefully this seems like it would be useful, and yeah.
Good. So let's see. Thank you very much. I think this, to my, I know this is the most complete training that we have done so far on our tables. So you're in very good shape when it comes to our table space. Have a look at Turn. Turn gives you lots of ways of how to use our tables. Look again over our examples. Please provide feedback if you use it in your company. Would be good. Write issues if you have particular requests. Let us know if our table suits your need or not.
Yep.
And thank you very much.